Welcome back. This is Mrs. Rubright with Geometry Honors. Today's lesson is 3.3, Prove Lines Are Parallel. Find the value of x that makes m parallel to n. So before, we used the fact that these two are corresponding angles, and we said, like, if parallel lines, then corresponding angles are congruent. So we're doing the opposite. We're doing the converse. Do you guys remember Converse? They're, Chuck Taylors. They're a shoe. Flip-flops are a shoe. For Converse, we flip-flop. Instead of if P then Q, it's if Q then P, right? We flip-flop it. We reverse it. So, with that being said, normally we say, if parallel lines, then corresponding angles are congruent. Now we're saying, if corresponding angles are congruent, then the lines are parallel. So to prove the lines parallel, the corresponding angles must be congruent. So instead of starting with it being parallel, we're saying they are parallel because they are congruent. So what value of x would make these congruent, therefore make these lines parallel? So all you need to do is 3x plus 5 must equal 65 in order for these lines to be parallel. So we subtract 5 on both sides. 3x has to equal 60. So x must equal 20. And that is the value of x that would satisfy this. So, when x is 20, then the lines would be parallel. Is there enough information in the diagram to conclude that line M is parallel to line N? Explain. What do we know? Do they have a relationship? Not yet. Where does 75? 75 could be here, right? Why? 75 and here are what? Corresponding. So, if these are corresponding, let's see, what should this be? Actually, let's take this back a step. Instead of assuming things and stuff, just to kind of check, it might make sense just to fill it in what you do know and then show it. So filling in what you do know. You know that these are a linear pair, right? And linear pairs are supplementary. So if it adds to 180, this has to be 75. Now that this is 75, the 75 and this 75 are in corresponding positions. Since they are congruent, therefore these are parallel. Make sense? I think doing it that way versus working backwards probably makes a little bit more sense. How can you tell whether the sides of the pattern are parallel in the picture of the diamondback snake? Okay, so it's really hard to see their drawing, but they have these little marks here. So they have a transversal, and they have these parallel or non-parallel lines. These are called what? Alternate interior angles. If alternate interior angles are congruent, then the lines are parallel. Alternate interior angles converse. Make sense? Can you prove that lines A and B are parallel? Why or why not? What are these angles? Alternate exterior angles. If alternate exterior angles are congruent, then the lines are parallel. Alternate exterior angles converse. It's the converse because we're proving the lines parallel. We're not beginning with the lines being parallel. Make sense? Can we prove them that they're parallel? What do we have here? Corresponding angles. If corresponding angles are congruent, then the lines are parallel. Corresponding angles converse. The measure of angle 1 plus the measure of angle 2 is 180. Can you prove they're parallel? These are alternate interior angles. If alternate interior angles are congruent, then the lines are parallel. So this is like a sometimes, because only if they were 90 degrees each, right? If they were anything other than 90, then this wouldn't work because they need to be equal, not supplementary. So this one's going to be a no. Supplementary angles do not have to be congruent. Prove that if two lines are cut by a transversal so that the alternate interior angles are congruent, then the lines are parallel. So we're trying to do a proof on this one. So we have our statements and our reasons, right? I want you guys to try to start this one out real quick. And we'll start going over it. Where are you starting? Where are we starting? Angle 4 is congruent to angle 5. Why? Okay, so we have 4 is congruent to 5 given. What's next? We can't say, okay, well, therefore they're parallel by the alternate interior angles converse, because that's what we're trying to prove. So we have to prove it with something else. Yes? Angle 1 is congruent to angle 4. How do you know? Vertical angles are congruent. Or vertical angles congruence, right? I should have put congruent, not congruence. There's either vertical angles congruence or vertical angles are congruent. Okay, next. So you add 1 and 4. So you have 4 and 5, 1 and 4. Well, doesn't that mean that 1 and 5 are congruent? By what? Angle 1 is congruent to angle 5 by what? Transitive. Sub a whole side for a whole side. Well, now that 1 and 5 are congruent, then G is parallel to H by what? What are 1 and 5? Corresponding angles converse. Right? It's the converse. If corresponding angles are congruent, then the lines are parallel. Corresponding angles converse. Make sense? Oh, is this it? So just showing you as a nice handwriting. They're doing 1 and 4 because of vertical angles. Then they're doing, they both have a 4, so 1 and 5. Transitive, right? So you're subbing a whole side for a whole side. And they're parallel by the corresponding angles converse. So you can see they did exactly what we just did. In the figure, R is parallel to S. Angle 1 is congruent to angle 3. Prove the lines are parallel. So we have our statements. We have our reasons. R is parallel to S. Given. Angle 1 is congruent to angle 3. Given. You can put them all on under 1 or you can separate them. It's okay either way. Alright, so we have 1 is congruent to 3. They told us that, right? And we know that R is parallel to S, so that's given. And we're trying to prove the other two parallels. So what do we know so far? We know okay. How about, I'm staring at it to see what I do know. With these being parallel, I know that 1 and 2 are congruent. How do I know that? Corresponding angles. Okay. Well, if 3 is to 1 and 1 is to 2, then 3 is to 2, right? Transitive. And if 3 and 2 are equal, and these are what? Alternate interior, then P is parallel to Q by the alternate interior angles converse, right? Because these two are equal and they're alternate interior angles. If alternate interior angles are equal, therefore the lines are parallel. Make sense? Someone get that? Alright, so on number 11, plan for a proof. Look at angle 1 and angle 2. If the measure of angle 1 is congruent to the measure of angle 2, because R is parallel to S. Hold on 1 second, sweetheart. Sorry about that, we're back. Alright, so plan for a proof. Look at angle 1 and angle 2. Angle 1 is congruent to angle 2 because R is parallel to S, right? R is parallel to S, so we know that these are equal. We know they are equal because they are corresponding angles, right? So then the next thing that they were looking at, this is just going through what we just did, except in a paragraph proof, right? So you're going to plan your action. It's given that R is parallel to S, so that the corresponding angle is postulate. Angle 1 is congruent to angle 2. Then you're going to say that if angle 2 is congruent to angle 3, right? If 2 is congruent to angle 3, then P is parallel to Q. So you're going to just write, if it's paragraph proof, you write it in words. It is also given that angle 1 is congruent to angle 3, and angle 2 is congruent to angle 3 by the transitive property of congruence for angles. Therefore, by alternate interior angles converse, P is parallel to Q. So you do the same thing as a two-column proof, but you just write it in words, in a paragraph. All right. So this is one of my least favorite things, not the flag. I love our flag. It's the problem that bothers me. So, the flag of the United States has 13 alternating red and white stripes. Each stripe is parallel to the stripe immediately below it. Explain why the top stripe is parallel to the bottom stripe. So for this, it's like, okay, stripe 1 is parallel to stripe 2. Stripe 2 is parallel to stripe 3. Therefore, stripe 1 is parallel to stripe 3. Stripe 3 is parallel to stripe 4. Like, and you keep going on and on and on, and it just bothers me that you have to do it that way. It's just really, really annoying. So, does that make sense, guys? You're like literally like 1 is parallel to 2. 2 is parallel to 3. Therefore, 1 is parallel to 3. 3 is parallel to 4. Therefore, 1 is parallel to 4. 4 is parallel to 5. Therefore, 1 is parallel to 5. 5 is parallel to 6. Get what I'm saying? Like, you just keep going and going and going by the same reasoning. So, therefore, the top is parallel to the bottom. Yeah. If you use the diagram at the right to prove the alternate exterior angles converse, write the given and the proof statements that you would use. So you're given, step 1, angle 1 is congruent to angle 8. Why? Given. Right? You go with this and it's given. We're trying to prove alternate exterior angles converse. So we cannot use that to prove that they're congruent. We have to prove it some other way. Alright, so it is given that angle 4 is congruent to angle 5. Where is that coming from? Where are the angles? Where's G and H coming from? That's so weird. That has nothing to do with this problem. This diagram does not match this. Interesting. Okay, so let's do this problem like that. So if these are parallel and they gave you that these are equal and they want you to prove the alternate exterior angles converse. So we would actually have to know more information, and they didn't give us any extra information. So I would go as far as to say that this problem is flawed. So ignore it because they don't actually give you enough information to prove it. All you know is that if those are equal, then yes, the lines are parallel by the alternate exterior angles converse, but you can't prove the alternate exterior angles converse without any extra information, so ignore this problem. Each step is parallel to the step immediately above it. The bottom step is parallel to the ground. Explain why the top step is parallel to the ground. So the same thing. Top step, like step 1, is parallel to 2. 2 is parallel to 3. Therefore, 1 is parallel to 3. And you keep working your way down. All right, so instead of doing it that long, drawn-out way, we do have a shortcut now. All of the steps are parallel. Since the bottom step is parallel to the ground, the transitive property of parallel lines applies, and the top step is parallel to the ground. So the transitive property of parallel lines lets you skip all the in-between steps, which is awesome, right? So sometimes when you guys have to learn extra things, it's actually like a blessing in disguise. So the transitive property of parallel lines eliminates the need to do 1 is to 2, 2 is to 3, therefore 1 is to 3, 3 is to 4, like, and so on and so on and so on. Transitive property of parallel lines. And that is everything. I hope you guys enjoyed your lesson on 3 pre-proved lines are parallel. Have a great day. Like and subscribe.